Okay, let's go through the study guide real fast. Okay, so what is the population pyramid / age structure diagram? You can see them below. And what do it show you? Oh, gross. What does it show you? I need to fix that. Okay, anyways, what does it show you? It shows you different populations in different countries and their projected growth. So if we're looking right here, the way you have it set up is you have 3 different groups. You have the blue at the bottom, ages 0 to 14. Those are our pre-reproductives. You have the ones in yellow. Those are our reproductive ages, right? 15 to 44. And then ages 45 to 85, we have our post-reproductive people, basically our older folks, okay? So kids, parents, grandparents. Now, if we're looking at this and you see one of these pyramids like so, you see a wider base and a narrower top, that means that population is experiencing rapid growth because these kids are going to want to have those many kids and then those many kids and those many kids, and the population is going to grow rather quickly. But what's interesting is we can tell a lot about this country too and see that it's a developing country. The way we know that is because there's so many kids being born, right? We have a large number of kids, which implies that there's a lot of women who are not maybe given the educational opportunities or the workplace opportunities that they would need to do much beyond having children. And there's probably going to be some kind of a high incidence of child mortality here, unfortunately as well, because we see that there are definitely a lot of kids being born, but not all of them tend to survive, according to this little diagram here. Okay? Now, what else can I show you? So you slow growth. That's where the base is only a little bit wider than the rest of the column. Zero growth, where they seem to be kind of about the same, and then negative growth, where the older people way outpopulate the younger people. And that means that as these older people, as this moves up, right, year by year, it starts to move up. As these older people start to die off, right, the young people will take over, but there's not as many of them. And that's a very dangerous situation to be because these people cannot provide the social safety nets that these people might need. Now, from a diagram, how do you tell the population is growing? Because that wider base tells you that it's growing. How do you tell if it's stable? If the reproductive and pre-reproductive ages are about the same, okay? And then declining if your pre-reproductive group is much smaller than your reproductive group. All right, everything's measured from the middle out. Males on the left, females on the right. Okay? What countries are currently growing? India, Kenya, Nigeria, Saudi Arabia, China, Brazil. All these countries are currently growing in population. Declining, we have a lot of our European countries, Germany, Bulgaria, Hungary, Italy, Japan. They currently have declining populations. What is population momentum, and what would that look like on a diagram? Population momentum basically says that if you have this many kids, right, and well, these kids are then going to have more kids of their own. And once that process starts, right, these things only get wider. So having more and more kids and more kids, as the population gets bigger and bigger and bigger as it rises. And it's kind of hard to stop. Like you can't like stop these kids from getting older, right? You can only affect maybe whether or not they choose to have kids themselves. But right now, this population growing means that the population for the whole country is going to have to start growing because these kids will have kids of their own, and it's going to start a whole process. So these countries would be said to have population momentum. Now, moving down to the demographic transition, be able to draw it from memory and explain all the transitions and what causes them. All right, if we take a look right here, we have the 5 stages of the demographic transition. You got to know why birth and death rates change, all right, and understand how it links to the population pyramids at the bottom. And remember, there is a transition of demographics, basically how populations and civilizations change over time. So looking over here, we have our initial, we'll call them pre-industrial civilization with high birth rates and high death rates, right? Kids often die, so you got to have lots and lots of kids. So therefore, they'll start pretty high. And then at some point, we get better with either medicine or maybe we start producing more food and fewer kids start dying. So the death rate starts to go down. You're having more kids survive. Now, birth rate is going to stay high because there are not a lot of opportunities for women in those cultures, in those civilizations. So birth rate stays high, but death rate starts to decrease. Now, if you're having fewer deaths, but you're still having just as many births, you'll notice the population will then start to just rise. Down here, it stayed pretty stable because birth and death rate were close together. But as soon as the death rate starts to drop, population is going to start skyrocketing. And we see that start to increase up here. Now, at this level, you'll notice birth rate also starts to go down. Mainly because at stage 3, we've reached the industrial stage. So we have pre-industrial, maybe a transitional phase, and then the industrial phase. In the industrial phase, women start to have opportunities, maybe in school or maybe at their job, right? And so what happens is they start to have fewer children. And so the birth rate starts to go down. And you'll notice a couple things here is that as the death rate goes down, it kind of plateaus down here. Birth rate goes down. But as the birth rate goes down, right, there's less of this difference between the two, right? The difference here is huge. Population is getting bigger really fast. But here, the actual difference between the birth and death rates are getting smaller. And so the population growth rate starts to level out, right? And as soon as the two birth and death rates meet, the population has flattened, okay? So that means there's no growth there whatsoever. In fact, if you look over here, we're not sure whether population will start to increase again or whether it'll start to decrease. It kind of depends on what people do post-industrial phase, post-industrial phase, yeah. Industrial, post-industrial, and then we don't really know. So we're not sure if it's going to go up or down. It just kind of all depends, okay? Yet to be seen, possibly falling further, possibly rising again. We don't know. But what we do know, pretty straightforwardly, is what to expect from here. So looking at our pre-industrial phase, you'll see this looks a lot like how Nigeria's looked, okay? Where we have this kind of wider base here, right, and smaller at the top, because a lot of these children tend to die in childhood with a higher child mortality rate in these kind of places. So we have a high birth rate and a high death rate. Now, right here, we'll notice the birth rate's still high, but the death rate falls rapidly. And when the death rate falls rapidly, you'll see that the kind of curve on the slope here, it flattens out because fewer people are dying. So they're staying alive longer. You get that more straight triangle-y kind of look. Now, right here, as the birth rate starts to go down, your birth rate falling and death rate still falling a little bit, that the actual increase slows. And you'll notice that the reproductives and pre-reproductives are about the same. That's why you get a flattening on the sides. And then again here, it falls more. We get more stabilizing, more stable population growth. Therefore, there's not much of a difference between the reproductives and the pre-reproductives. And then down here, you may notice a little bit of a shrinking in the pre-reproductives because, again, we're possibly having a declining birth rate. Okay? It just depends on what's going on. All right. And I think we talked about why those things are happening. How do developed and developing countries compare in infant mortality rates? So here we have a developing country. We see we have a high infant mortality rate because there's not many infants surviving to older ages. In a developed country, you'll see anybody who's born pretty much survives on the way up. So they have a low infant mortality rate. Women's opportunities for reproductive rights. Again, the more babies you see being produced, the wider the base, the less opportunities for women in those countries. Okay, you're given less options other than just having children. So developing countries will have low reproductive rights and low opportunities for women, and developed countries will have more such things for their women, which means they're having less children and the population is not growing as much. Child labor, which is one that I found interesting. So child labor, I saw this in the standard, specifically about this. In developing countries, there may be some child labor. Kids have to work because that's why their parents had them to begin with. They could be working on the farm, working in a factory, but either way, the child is expected to contribute to the family. Now, what does a pre-industrial country look like? Well, it's mainly farming, agriculture-based, right? Industrial, that's when you're working in factories, doing the same thing over and over again. How do developed and developing countries relate to industrial and pre-industrial? Well, developed countries would be your industrial countries, right? Or post-industrial. Developing countries would be pre-industrial, or maybe in the transitional phase. Okay, what is clear cutting? Literally cutting all the trees down. How does it contribute to soil erosion? Well, if you cut all the trees down, right, then you have no roots to hold the soil in, so the soil will erode away, and that's bad for your farming. If you clear cut all the trees down, well, the trees are then going to decay, and decaying trees produce CO2. Not only are they producing CO2, but they're no longer breathing the CO2 in, so that's twice as bad to clear cut. What issues are caused by increasing CO2? When CO2 levels go up because you clear cut, right, then you're going to have the problem with global warming because carbon dioxide is a greenhouse gas. Increased soil and stream temperatures. This one is big and I don't think people are going to remember it. I want you to remember it. Basically, when I cut down the trees, there's less shade. Less shade means the soil gets hot. Less shade means the water gets hot. Plants don't like to grow in hot soil. And creatures need a certain temperature range in the water in order to survive. So if it's too hot, it's a problem for everything. And so organisms will die and experience stress. What is climate change? Climate change is basically what happens with global warming. As the earth heats up, things start to change, right? Areas that were once dry become moist or wet. Areas that were once wet become dry, and just the climate overall starts to change, right? And that's a problem everywhere. Moving on here to mining. What is an ore? It's just some kind of mineral you extract from the ground, like the chocolate chips and our cookies. Can you think of examples? Coal, iron, gold, all those things we dig up out of the ground. We have two means of accessing the ore. What is surface mining? That's where we're digging around on the surface because it's easy to find. Two forms of surface mining. You have strip mining, right on strips, and mountaintop removal, where you just blow the top off. How does strip mining work? You're just, again, taking away the overburden over top of the coal seam or the iron, whatever it is you're looking for, and you just take the strip off, dig the stuff out, and put the overburden back. How does mountaintop removal work? Well, if you know that there's stuff inside that mountain, well, just blow the dirt off the top and reveal all the minerals down deeper. Which causes more problems, strip mining or mountaintop removal? Mountaintop removal 100%, because blowing things up casts tailings everywhere. Strip mining with overburden can be more controlled, but the more you have just explosions and tailings everywhere, the more you can pollute the surrounding waters and environment. What is subsurface mining? That is digging down deep under the earth. That's where the coal miners go, like deep down, like hundreds of feet down. And what are the possible negatives for them living there? Well, they can become trapped, or working down there, I should say. They can become trapped. They also breathe in nothing but toxic chemicals, right, from all that coal down there, which can cause cancer or respiratory issues, all those kinds of things. What is overburden? That's just the dirt on top of the ore you're trying to mine. Tailings are any dirt, right, or materials or minerals that get flung away. They can be radioactive, they can be toxic metals, but these minerals, these toxic things and tailings sometimes end up in the rivers and streams, and they can cause organisms to die, which is a bad thing. What do we do about them? We put the tailings in, we collect them all up, and we put them in a pond and just let them sit there, and hopefully they just, over time become less deadly. That's the general idea. Think of it like a landfill, but for tailings. What is slag? Slag is what's produced after you try to purify a mineral. So if you get an ore, which is just like a bunch of dirt and rocks all together, you melt them all down and they layer out in terms of density. I think we see something like this. Let's say that I melted this down and I found that the steel or whatever, the iron that I was looking for went to the bottom. I would scrape all this slag off the top. That's the stuff I don't want, and then I throw away. This stuff on the top can be toxic, right? Slag can be toxic just like tailings, and we have to dispose of it the same way. Put them in tailings ponds and hope that they don't infect the environment. What are 4 negatives to coal mining? Not use. 4 negatives to coal mining, not coal use. Coal mining specifically. When you coal mine, you destroy the habitat because you have to get the coal underneath the ground, right? You can contaminate the groundwater with your tailings, with toxic metals, right? Radioactive particles. You can release dust particulates. So basically, when you're mining coal, all that stuff goes into the air. And anybody in the area, your coal miners included, or people who live out there, they're going to breathe in those dust particulates, and it's going to cause respiratory issues. And release of methane. Methane, we know, is a greenhouse gas, a really potent greenhouse gas, 20 times stronger than carbon dioxide. Why can't we find coal on the surface anymore? Because we've just dug it all up, right? So now we have to mine deep down, and that's what's causing a lot of problems for our miners, is having to mine so deep and so dangerously. Okay, what is urbanization? That's building a city. Cities use a lot of resources, and that's the main problem. That's where we're going to go off from here. Saltwater intrusion. How do cities cause it? Remember, cities are oftentimes built next to the ocean. Okay, here's the city on top of the land, and so when they're sucking water up to fill the city, sometimes it pulls water from the ocean, that's salt water, into this land. And so this land over here starts to get salty from saltwater intrusion. Again, pulling up H2O, all right, pulls up H2O from the ocean, and that can be salty and causes problems for the local habitats and farmland. Okay. To build a city, there are a lot of machines needed. To move around the city, a lot of machines are needed. Therefore, cities contribute to a lot to global warming because there's just so many machines around that need fossil fuels. All that pavement contributes to what issue? Well, pavement is what we call impervious surface. So an impervious surface means that water can't get through it. And if water can't get through it, that means there's lots of runoff. So all that pavement contributes to lots of runoff. You ever seen the streets, right? After it rains, there's just water flowing everywhere. And that water picks up toxic chemicals from our oil, right? From trash that we throw on the ground, right? To poop and pee from what people or animals leave on the street. And all that stuff washes into our rivers and streams. It can cause eutrophication, right? It can add stressors to the creatures who live there from all the toxic chemicals and can cause them to die. Can I think of a solution to the runoff problem? Well, we probably need to have less pavement, I should say, and more grass, more trees. Oh, how about this? Green roofs are a great solution to this, right? Because again, they'll absorb some of that water and prevent some of the runoff from becoming such a problem for the environment. So you could also have concrete maybe, or a pavement that is more porous, has holes in it to allow a little bit more of that water to pass through. And we do have pavement like that, it's just very expensive. What is an impervious surface? One that you cannot penetrate through. Where do you find them? And pavement in cities. And what can you do to pavement to make it allow for more infiltration? You can put little holes in it, like actually design it to have holes in it to allow water to pass through. Can you explain the issues that a parking lot can cause? Well, building a parking lot, you got to destroy a habitat. Number two, you have to have machines, which contribute to global warming, lay down the pavement. Number three, the pavement itself can be an impervious surface, which can cause more runoff. Number four, all that runoff can go to rivers, lakes, and streams that can poison those areas or cause eutrophication. So all those things are bad. What is urban sprawl? That's how cities tend to grow outwards because affluent people want to move out and further away from people in poverty. So people in poverty typically live in the center of the city, and then they move their way on out into the suburbs where the wealthier people exist. And what causes more problems? High density cities or spread out suburbs? Even though cities are not great, they are certainly better than the suburbs because if you have a whole bunch of people living in one building, they don't take as much space, right? To spread out in the suburbs means we cut down all that habitat and take away the land for so many more creatures and take away their living space, their habitat. And that affects those populations. What issues can runoff from the suburbs cause or contribute to? Again, killing off plants and animals in the streams. Sustainability just basically means we can do that thing over and over and over again and never run out of that resource. We are doing something sustainably, trying to keep our yield constant. Why is it important? Because if we're behaving unsustainably, eventually we'll run out of material, whatever that happens to be. A sustainable yield is one where you're getting a certain amount of material out, but without taking away from the overall load. So for example, a sustainable yield of fishing, we only take as many fish out as we need to so that the ones that are still in there can reproduce more fish for the next year. So just like our goldfish thing, right? You only take a certain amount out so that they can repopulate the next generation. And that's what's called sustainable yield. It works with a lot of things, including in mining and forestry especially. So what is sustainable forestry? What techniques can you use to make forestry more sustainable? We could do, sustainable forestry just means we're getting our trees without destroying the whole forest, right? And getting the amounts that we need when we need them, without taking away from the overall share. What techniques can you use to make forestry more sustainable? Basically, we can do rotational forestry, right? Where you're only getting trees from one area at a time and letting the other areas regrow. You can do selective cutting is what they call it. This is an important one, so I would remember this. Selective cutting is really important. Because what that means is you're just going into the woods and choosing the trees that look diseased or damaged, or just taking a few trees that aren't going to be contributing to the population. So you just go out and very selective in the ones that you pick, okay? Talking about solid waste in landfills. What is solid waste? That's trash. Where do we put it? In the landfills. What environmental issues can landfills contribute to? Well, building them destroys the habitat. B, all that leachate can actually destroy the groundwater if it makes it through the liner. And then C, global warming from all the methane growing up inside of it. What is e-waste? E-waste is electronic waste, and that is from our computers and cell phones and stuff. What happens to our e-waste is it gets thrown into these landfills, or it gets shipped to other countries. In these other countries, they'll do things like burn it. They'll burn the plastic off to get some of the metal inside, the copper wire that they can sell, or the gold, whatever happens to be in that electronic, or in those electronics. And then when they burn these things, these toxic metals oftentimes go into their bodies, and it causes lots of health problems for the people who live in those areas. What do kids in other countries do with all our e-waste? Well, they burn it, as we said, and it could cause respiratory issues, reproductive issues, mental issues, all those things. If we don't recycle our e-waste, how are we going to get more raw materials for new computers? So if I don't, when my iPads are all done, right? If I don't send these to a recycling plant, these are going to get thrown into a landfill and stay there for forever, which means that Apple is going to have to hire someone to go out into the woods somewhere and start up a mine and mine more of the minerals they need for that laptop or for that iPad. So if we don't recycle our e-waste, it's going to cause a problem because we're going to need more stuff. Okay, and more stuff causes more environmental problems. Be able to model a sanitary landfill, all right, and cover all the main things that mitigate the issues caused. Number one, we have our liner, all right, we got our liner all through here. We have our clay also underneath it. Any of this leachate gets collected and pumped out so it doesn't destroy the liner. We also collect all the methane gas to generate electricity, and then we cover it over top when we're done with grass or maybe, let's say, solar panels, something like an environment to just like contribute to what's going on. Oh, also, they monitor a lot of times the groundwater underneath to make sure that there's no contamination. How can we increase the decomposition of waste in a landfill? If you want to make the decomposition in here happen faster, make it wetter and make it hotter. And both of those things will help the decomposition process happen. What can incinerating the waste help us with? Well, if we burn it, we have less terrible stuff, right, in our landfills, which is great because then you have less leachate and less other problems. But incinerating our waste can cause more CO2 to happen, right? Do landfills accept all waste? No, not rubber tires. And why not? Because they can contribute to mosquitoes. And the people who work there would suffer from all those mosquitoes and diseases, so they don't even accept them anymore. So what do people do with them is they just chuck their tires into the forest. And what do mosquitoes have to do with these tires? Well, when water from rain lands in those tires, mosquitoes lay their eggs in the stagnant water, the standing water there, because no one's out there overturning those tires. And so mosquitoes, they come back in force. Why does the ocean get so much trash? Can we do anything about it? Well, all the stuff that we have on land gets washed into the streams and rivers. Rivers all lead to the ocean, so all our ocean ends up in the trash. And you remember that turtle, that poor little turtle had that thing pulled. Okay, can we do anything about it? Yeah, right? Recycle, reduce the amount of stuff that we use, reduce the amount of trash. Your single-use plastics, for example, we shouldn't be using those. Okay, not anymore. All right, reduce, reuse, recycle. What can floating trash do to habitats or organisms in the ocean? Well, it can kill them, as we've seen. All right. Hopefully this is the final one, because I'm running out of steam. Here we go. What are the 3 R's for environmental protection? Reduce, reuse, recycle. And reduce is the most important one. Reduce your consumption, reuse when possible, and recycle if you have to. How are recycling and landfills related? Well, the more you recycle, right, the less you got to put into a landfill. How does recycling affect mining? The more you recycle, the less you got to mine. That's good. We want less mining. We want less landfills. So recycle. What is composting? Well, that's where you take all your food waste and put it in basically just a container and let it decompose. And then you use that and any, like, let's say grass clippings you got or like weeds that you cut out, you let them all decompose in a container and then you use that as soil or fertilizer for your soil in your garden, in your house. It helps with our landfills because some of that food doesn't have to go into the landfill and contribute to our problems with landfills. They're over full. So we have to always build more of them. So the less stuff we put in landfills, the better, through recycling and composting. What hazardous chemicals can be found in e-waste? You have all these what we call toxic metals, heavy metals, okay? How can we prevent them from being released into the environment? Well, if we recycle our e-waste, we don't have to send it to these poor countries where they have to burn it, and that's the main problem. What landfill mitigation strategies do you know? Removal of leachate, right? Pumping out the methane and using it to power the facility, and covering the cap with some kind of environmentally friendly forest or maybe a solar panel cover. What can we do with the methane producing these landfills so we can generate electricity? Oh, we're still not done. Okay, this is our last one from today. Model the sewage process from beginning to end. Be sure to highlight the primary, secondary, and tertiary treatments in each section. Okay, so first off, primary treatment. We first take the raw sewage, we screen out all the trash, get rid of it, and then you send it to the clarifier. So the clarifier, you just let it settle, okay? And all the really heavy stuff gets scraped off the bottom, all the really light stuff gets scraped off the top, and you're left with this poopy water. Poopy water goes through into the secondary treatment, which is your biological treatment. That's where you aerate it and let the bacteria inside do what they do, which is, eating poop. So anyways, then it goes to a secondary clarifier. And the secondary clarifier, again, it's let this settle out. Whatever the bacteria have eaten, the particles, then sink to the bottom where they scoop it out, right? And they send it to treatment and disposal down here at the bottom. So same thing with primary clarifier. Any of that stuff on the bottom or the top gets sent for treatment. And then the clean water up here that the bacteria just cleaned, all right, goes to your, I should say this is your tertiary treatment right here. Secondary treatment is the aeration tank. Secondary clarifier is your tertiary. I don't know why they have that separate. But this secondary clarifier should be your tertiary treatment. And then your disinfectant, that is what you add to get rid of the bacteria before you release it back into the water. Okay, so primary treatment is the screen and the primary clarifier. Secondary treatment is the biological treatment. That's with the bacteria when you aerate it and activate it, basically. And then the tertiary treatment is the final settling tank, final clarifier, where it settles out. And then you add a little bit of UV light or ozone or maybe even chlorine to that water to kill off the bacteria who are left. And how does oxygen aeration help this process? It helps the bacteria right here decompose that stuff faster. That's it. Cool. I'm tired. Sorry that was fast. I hope it helps. And y'all, best of luck. Study, 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 study.